All right, what's up, everybody? Today is December 12th, 2024, and I wanted to do a little presentation as a follow-up for a post I made about quantum computing and the threats of Bitcoin. So I prepared a little slide presentation, just 7 slides, very short, to take a look at exploring and explaining explaining and exploring the risks of quantum on Bitcoin. I think it's going to be very interesting. So this is nothing new. Some people have been talking about this a lot longer than I have, but I'm just kind of getting into it, digging into it a little bit as a follow-up to this Google Willow announcement the other day, which in short is a bag of nothing, but quantum computing is not a bag of nothing. So let's get into this and take a look. So quantum versus Bitcoin, right? So I think the first question is, what are the impacts of quantum computing potentially on Bitcoin? Well, basically, it's inevitable that quantum computing will eventually be able to crack our current cryptography, right? So cryptography that's used in Bitcoin today. So I'd like to go through and explain what that cryptography is, how it works, how quantum can attack it, and what this means to the Bitcoin that's out there in your wallets and everyone's wallets. So let's take a look at this a little bit. And I think I'd first just like to start by explaining that there's two types of cryptography used in Bitcoin. One is SHA-256, which is used as a hashing algorithm to create blocks. That's actually quantum resistant already, so that does not need to be changed. Is what it seems like to me. If I might be wrong about it, but it seems to me like this. There's quantum resistance already built into Bitcoin's hashing, and that's how blocks are produced by finding this thing called a nonce. Look it up if you want some more details, or I could do a future video on it. But basically, hashing combined with the difficulty adjustment, we're already kind of quantum proof for Bitcoin mining. But then the way that Bitcoin addresses are derived and the way that these transactions can be signed is another topic where quantum actually does have an attack that's possible. So there's these sort of transactions in Bitcoin are the way that ownership is proven. So because you can move a UTXO by signing with your private key, that is how you prove ownership. So it's like a secret handshake between these two keys, the public and the private key, that proves that you verifies that you own something because you're able to move that Bitcoin. Right? So those two keys are, well, there's a private key, which is a secret, and there's a public key that's shared. Sort of like the private key is your password, your email, and the public key is your email address. So obviously you don't give everyone your password, but your password is how you're able to log in your email and send an email. And so the danger of quantum computing is that there's something called Shor's algorithm. And this is a way where this quantum sort of villain, these quantum computers would be able to take your public key and expose your private key. So it'd be like looking at your email address and then being able to detect your password. Kind of like guessing at your password really quickly by doing a bunch of math based on your email address. And so that's actually what will be possible in the future. So now the question is like, how much of Bitcoin's addresses, how many of Bitcoin's addresses are actually vulnerable to this? Well, it turns out that every address before the year 2012 is vulnerable. So in 2012, there was an advancement to Bitcoin addresses and privacy called P2PKH. Before that, there was just P2PK, and these just stand for pay to private key, or pay to public key, and pay to public key hash. So since 2012, almost all addresses do not include the public key unless you spend from that address. So every address before 2012, the public keys are known. Well, guess what? Those are actually vulnerable to being attacked by quantum computers. And after 2012, if an address has been used to spend coins from, then that address is also valuable. You're wondering, what are you talking about, Ben? Like, how could I not have spent from my address? Well, typically addresses spend all of their Bitcoin and then return that change to another address controlled by the wallet. That's the recommendation of how Bitcoin should be used. But of course, exchanges and most wallet users don't use Bitcoin this way. Most of us use Bitcoin where we have an address, we send a couple payments from it, and that balance remains in that address with UTXOs, and we send a few more payments. But really, we should only use addresses just one time. Otherwise, they are vulnerable. So those addresses that have been spent from and anything pre-2012 are all vulnerable to quantum attack because the public keys are known. That's the thing. When you spend from an address, you reveal the public key in the transaction, which makes that address vulnerable to this attack where they can guess the private key using quantum computers. Pretty wild. So how are we going to fight back against this? I think that's the real question. What can be done? And the answer is there will have to be hard forks or soft forks to Bitcoin. So there will be forks, and these forks will require everyone that has Bitcoin to move that Bitcoin to a new quantum resistant address. And there will basically be a block number or a date where the old addresses will not be able to move Bitcoin anymore. And that includes Satoshi's Bitcoin. So it seems like an unavoidable aspect that, there's going to have to be a way to shield Bitcoin from these quantum attacks, and this will lead to at least one fork, maybe more than one, and we're going to have a period of instability and a period where we don't know. So this is why it's really important now to be investing in research and development on post-quantum cryptography and implementing these in Bitcoin. It's actually, from a technical standpoint, not a huge deal to implement, but the huge deal is sort of getting the consensus from all of the different actors in Bitcoin. So there's no one who rules Bitcoin. There's no one who can say, okay, we're going to flip a switch tomorrow and we're going to go from all gas cars, taxis in the city to all electric cars like they did in China in 1 year, in Shanghai, I'm pretty sure, Beijing. That's not going to happen. So as a wrap up, what can you do is you could stay informed. If you have the capacity to donate to Bitcoin research and development, then that could be great to put out some of your funds to make available to people that are actually working on this thing. And I'd love to learn about some of those so I can promote them. So if you are working on any quantum resistant Bitcoin research, I'm not talking about some other quantum proof chain. I'm talking about for Bitcoin. Then I'd love to know about it and promote it. And just staying informed and being thinking about the security of the future. So this is not over. This is an evolving topic. This is going to require something from all of us in the future to weigh in on the direction that Bitcoin takes as operators of nodes, as users of wallets, as holders of Bitcoin, miners, developers. Everyone's going to have a say in this future direction that Bitcoin takes, and I think it's going to be very interesting. And of course, as Bitcoin forks, those forks will have some value, even like old legacy Bitcoin, which will eventually happen. There will be a legacy Bitcoin where there's all these old addresses that are still spendable, and there'll be some new Bitcoin that's quantum resistant where these old addresses are not spendable from. So that's what I think is going to happen. If you think any differently, please comment. Subscribe to my YouTube, and let's have more conversations about this. I think this has been very interesting. We had a great space today on X, so make sure you're following me for more information about quantum and sort of Bitcoin-related topics, and we'll see you guys soon. Thanks.